Welcome to the series of videos on C++ programming language. In this video, we'll study arrays of higher dimensions. So what is the plan? First, we'll study basic concept, then basic syntax of two-dimensional and three-dimensional arrays, followed by some different types of declaration and initializations, indexing function or how to access the elements, then character arrays and their properties, and a few working programs. So what is a two-dimensional array? A two-dimensional array is nothing but a one-dimensional array of one-dimensional arrays. So in short, we call it 2D array and 1D array. Similarly, a three-dimensional array is nothing but a one-dimensional array of two-dimensional arrays, which are in turn one-dimensional arrays of one-dimensional arrays. Likewise, n-dimensional array is a one-dimensional array of n minus one-dimensional arrays. So now let us see some syntax of two-dimensional arrays. As usual, data type followed by legal name, and here I need to give, it is a two-dimensional array, I have to give two sizes. Left hand side size 1, and from on the right hand side this is size 0. These sizes refer to number of elements of this data type to be present in particular dimension. Usually this right dimension we call it columns, just to resemble it with, make it resemble with the two-dimensional arrays or matrices of mathematics. This dimension is referred to as the number of rows. Okay. So here it is one way of declaring a two-dimensional array. Next one is data type, some legal name, and these integers size 1, size 0, and we can initialize also. We can supply values within this outermost pair of braces followed by semicolon. We have as many list of values enclosed within pair of braces as there are number of rows. It means these inner pair of braces and list of values therein must be same in number. So if this size 1 here is 3, they must be 3 in number. And inside inner pair of braces, we have list of values separated by commas. How many values? Those values must be same in number as size 0. Next type of declaration and initialization is name, data type, name, size 1, size 0, of course, and a single pair of braces, and inside this you have list of values separated by comma. These values must be in number equal to size 1 multiplied by size 0. Those many elements. If we supply less number of elements, it depends on the compiler what values it assumes in place of absent initializations. Next one is we gave a data type, name, and then leftmost dimension we may not give the value for. We can skip it, but this is essential, size 0. Again, the number of values, now it knows that how many values I should provide here inside this equal to size 0. So it will deduce, so you are providing 1, 2, 3, 4, as many rows as you wish you can provide. Accordingly, the compiler will deduce what should have been written here. Okay. Next one is the data type, legal name, again missing dimension from the left hand side, leftmost dimension, and size 0, then pair of braces and all possible values. So here if you have given size 0 some value, then list of elements can be any in number. Accordingly, it will convert them into number of rows and number of columns accordingly. Suppose we wish to represent the following 2D array of integers in C++. So it appears to be like this, but remember it is not like this in memory. When it comes to store in memory, it is not like this. Okay, so it can be done like this. So here what I have done here is I have declared an integer named a of 4 rows and 3 columns. So there must be 12 elements. So we can count from 10 up to and including 120. There are 12 elements. Okay. So how they are stored? C++ is just like C. It is also row major. It means in the linear memory, first row would be stored first, followed by the second row, third row, and fourth row. So you can see here 10, 20, 30, they will be represented like this. Okay, and here next row would be represented here, and so on. So 80 here is here, it is in the third row and column number 1, that is second column. Okay. So what we have done here is we have declared an array A of integers of 4 rows, 3 columns, total elements 120. Let us rewrite the same array which we declared in the previous slide. Now here I have represented it again for sake of simplicity. Now you can see here in the linear memory, suppose the name of the array is A. So how far is 10 from the beginning? At 0 location. Okay, 20 would be here, 30 would be next, because as I just told you, it is row major. Okay, so first row is stored first. So the yellow cells, first row, row number 0, 10, 20, 30, followed by 40, 50, 60, that is green color, you can say. So second row, that is row number 1. Similarly, this one, red color, row number, the third row, row number 2, and the last is from here, these 3 elements. Okay, so you can see here I have written here like this. Since it is row major, row number 0 would be stored first, and inside that columns would be saved, stored, column 0, column 1, column 0, this is column 1 and column 2, followed by all elements of row number 1, followed by row number 2, followed by row number 3. So now you can see here, suppose if I want to reach to element 80, so how far is it from beginning? It is from beginning, it is 0, this one, 1, 2, 3, 4, 5, 6 and 7. Okay, so 80 is at distance 7 from 7 element from the beginning of the array. So though it is 2-dimensional array, but it will be stored in linear memory, that is each element is stored one after the other row wise. Now let us take an example of a 3-dimensional array of integers. Let the name be A again, and here I have used the technique of not declaring the size of the leftmost dimension. So how many rows are there? 2, which will be indexed from 0 up to and including 1. So row index values would be 0 and 1, max, only 2 possible values. In case of columns, minimum column index value would be 0, maximum will be 1, because counting begins from 0. So how many elements are here? It means for each third dimension value we have to have 4 values. So this would be let us call the leftmost dimension as plane. So each plane will have 4 values. So this is first plane, plane number 0. This is second plane, plane number 1, and this is the third plane, that is plane number 2. So suppose this is our first plane, and these are the 4 values, and this is the second plane, these are the 4 values, and this is the third, that is plane number 2, plane equal to 2, plane index equal to 2. So third plane. So total 12 values are there. So how will they be stored in linear memory? So here is the name of the array. Okay, distance from starting of the array of any element or any plane would be like this. So plane 0 would be stored first, these 4 elements you can see here. Next plane, these 4 elements, and next these 4 elements would be stored at the end. Now inside these 4 elements for first plane, now I have written here, so this is the plane 0, this is plane 1, and this is plane 2. Inside each plane, since it is row major, first row followed by the next row. This will happen in each plane. Row 0, row 1, here it will be row 0 and row 1. Inside each row, column 0, column 1, and so on. So again, suppose if I want to reach to 80, which is this element here, how far is it from the beginning? 7 distance is 7, counting begins from 0. So it's 10 is at the beginning, 20 is one element away from A, I mean starting of the linear memory, 30 is at distance 2, and so on. How do we reach to 80? So if its indexing function index is would be it, what is the plane number? So 1. It is under plane number 1, and under plane number 1 it is under row number 1, and it is under column number 1. So index for 80 would be, how to access A within the square brackets like here, 1 1 1. How to reach it to it? How to reach to it in linear memory? 80, if plane index is 1 and row index is 1, so plane index is 1 multiplied by dimensions of all previous planes. So dimension of all previous planes is 2 by 2, isn't it? So how many planes are there? 2 planes are there. So 8. Okay, 4 multiplied by 2, 8. No, it's not like this. So we will see when we study the view the, or you can say see the working program. So how many planes are before plane number 1? 1. What is the size? 4. So 4 multiplied by 1 plus, what is the row index? 1. So how many rows to skip? 1, which means size is 2. So 4 plus 2, and column index is 1, so add 1, so 7. So 0 through 0, 1, 2, 3, 4, 5, 6, and 7. This is the way we can access three-dimensional elements of three-dimensional array by making use of appropriate indexing function. Now let us see some working programs. In this program, what I have done here is I have first declared an array of type integer of 4 rows and 3 columns, but I have yet not initialized any element. None of the 12 values have been initialized. So in response to this nested for loop, these nested for loops, what will it print? We do not know. It depends on the implementation of the compiler. Next, I have declared an array B of 4 rows and 3 columns each. So this is one possible way of initializing the values. So how many rows are there? 4, and each row has 3 columns. But we have initialized these values. So in response to these nested for loops, it will print all these values in the form of, appearance would be something like a 2-dimensional array. In the third case, it is also an array of integer, 2-dimensional array of integers, but here the left dimension I have not declared as far as its size is concerned. I have not declared its size. So 3 columns each. So how many rows? So we say 3 first row, 1 row, row number 1, that is second row, third row, and these 3 elements in last row. So how many rows are there? 4. Same values. So again these nested for loops will print the values of all the elements. Let me scroll it a bit so that you can see the remaining program. Now you can see here In fourth case, what I have done here is it is a two-dimensional array of 11 elements. You can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Whereas it must have elements in multiple of 3, that is number of columns in each row. So for the last element, what will it do? We do not know. What value it will assume or substitute, we do not know. So these nested for loops will also print the values. The last one is, it is a three-dimensional array. Okay, so you can have to print all possible values, you have to have 3 for loops, just like here we have 2 nested for loops for printing the values. Since it is 3-dimensional, you will have to have 3 nested for loops to print it. Okay, so I have not written those nested for loops here. Again, I have used another way of initializing the values. So number of rows is 2, number of columns is 2 in each row. So 4 elements in each plane, we can say. For each value of leftmost dimension, there will be 4 values. So we can group 4 values into one plane, we can say. So this is first plane, this is the second plane, and this is the third plane, isn't it? So 3 planes, each plane has 2 rows and each row has 2 columns. So total again 12 values. So in this case, what index values for leftmost dimension would be 0, 1 and 2 possible. So minimum index value for the leftmost dimension would be 0 and maximum would be 2. For each row, for each plane, row index values would be, minimum will be 0 and maximum would be 1, because there are 2 rows in each plane. Counting begins from 0. And each row, minimum index value would be 0 and maximum index value will be 1. So here what should it print? So as for the indexing function, so it is in plane 1. So plane 1 means this was the plane 0. Okay, this is the plane 1. So it will land up somewhere here. Then row number 1, second row means, and it means 70 and 80, because this is row number 0, this is row number, next one is row number 1. Then column 1, so it means now 80. So here it should print, in response to this, it should print 80. How? You can see here, if you want to print from ith plane, so take the value of I multiplied by size of all the previous dimensions. So here, what is the size of previous dimension? 1. So all previous dimensions are 2, 2. So 2 multiplied by 2 multiplied by 1. So that is 4. Then plus row index value j multiplied by all values of the size of its previous dimension. So it is only number of columns. So it is 2. So 2 multiplied by j plus k, that is the column index, that is 1. So here what will be the value? 2 multiplied by 2 multiplied by 1, which is 4, plus 2, which is 6, plus 1, 7. So 7 elements away from the beginning of the array in linear memory, and counting begins from 0. So this is 0, here it is 1, then 2, then 3, 4, 5, 6 and 7. So it will print 80. Now in response to this, it is within the range. Minimum index, possible index is 0, maximum is 2, so it is 0, it is in the range. Here it is minimum is 0, maximum is 1, it is within the range. Here minimum is 0, maximum is 1, but it has a value of 5, which is beyond the range of column indexes. So it appears, some people think that it will print some arbitrary value or it will be a syntax error. No, use this indexing function again. So here it is 1 multiplied by 2 multiplied by 2, which is 4. So here 2 multiplied by again this 1. So 4 plus 2 is what? 6, followed by 0. I took the wrong line. Here it is 0 multiplied by 4 is 0, plus 2 multiplied by 1, which is 2, plus 5, which is 7. So it will be 7 again. Value of the indexing function is 7. So again it will print 80. Now in this case, this index value is within the range, this index value is within the range, but it has gone beyond the range. So it is also not error, no random value, because substitute these values now. So 2 multiplied by 2 multiplied by 1, which is 4. Then 2 multiplied by 1, which is 2. So 4 plus 2 is 6, plus 5. So value would be 11. So now you can see here, this statement is supposed to reach here 11. Okay, so last value it should print. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Sorry, I have mapped it wrongly. I have to come here. Okay, so 11, this will be here 0, then 1, 2, 3, 4, 5, 6, 7, 8, then 9, 10 and 11. So last value it will print, that is 120. And in this case, of course, it is 15. You can check, and 15 is beyond the range, that is the size of the entire array. It has 12 elements, so indexing function will result in a value 15. So it will print some arbitrary value. So now let me execute the program. Now you can see here, in case of first nested for loop, since we did not initialize any values, so it has printed all those 12 values, random values. All 12 values are random. Next time if you execute this program, again these values may be different. Okay, now next one, these values, 12 values. So this nested these nested for loops will print these defined values. Here also it will print, because this is different way of doing this, this will again print the same values. But here what we have done here is, in the, let me clear this, and let me scroll it a bit. So yeah, here we have provided 11 values. So these nested for loops will print here. But you can see here, the last value it has assumed as 0. Though it is random, it has assumed 0. So this particular implementation is assumed in this particular case. Let me re-execute it. Now you can see here, again 0. So it means in this case, under the current setup, current compiler, it assumes 0 value. Okay, but we cannot rely on it. Okay, now you can see here what is it doing? It is, for the first value, it is printing what? 80. Next value also, it is printing 80. Then the third value, it is printing last element value, it means 120. Here it is printing some random value. We can rerun it. You can see all values, top 4 lines, rows. Here you can check. Okay, here you can check. All these values will keep on changing. See here, all values have changed. So these are the random values because we did not initialize. What does it mean? It means in case of 2-dimensional array or 3-dimensional array or 4-dimensional array, any number of dimensions, the values which we have not initialized, they may be treated at random, or it will depend on if the index values are within the range. We do not know what value would be substituted by the compiler for non-initialized values. But if the indexing value, index function value, is beyond the range, that is the size of or number of elements of the array, then it will print some random value. What value? We do not know. So in this program, what we have done here is I have declared one array of type character of size 4. Okay, so actually we can assign 4 characters here, but I have not initialized any of the values, and so it is suppose this is C out is supposed to print arbitrary characters. Okay, in second str2 I have not declared the size of the array, but I have initialized. So here capital A, B, C, D are the values of the 4 characters. So the size of this str2 character array would be 4. Actually it occupies 5 bytes and last byte is reserved for new line character. So by making use of some function, if we want to calculate the, or if we want to find out the size of str2, it will return 4, but internally it reserves 5 bytes. Okay, so here it will start printing from, just like C, it will start printing from the first position. It is nothing but the address of the array, and it will print until unless it encounters null character in the memory. So it will stop after printing capital D. Here again I have not defined the leftmost dimension. So rightmost dimension is 4. So but I have provided only 3 characters in all the cases. So I have asked it to reserve 4 columns for this dimension, 4 characters each. So this is nothing but an array of character strings which are themselves character arrays. So it is 2-dimensional. So how many? What will be the value of leftmost dimension? 4. So it could have been written as str3 4 4. Now pay attention here. I have provided only 3 characters in each column position. Each row has 3 characters each. So what will it do? It will reserve 4 spaces, and last character position, 4th place, is initialized as null, and then the 5th one might be in this case. So here it will occupy 4 characters, and last character of each string would be null character. So in response to this str300, it should print capital lowercase a. In this case str31, so this is string number 0, string number 1, it is supposed to print EFG and then the new line. In this case str0 and 5. So in, let me erase it. When we declare it like this excuse me, minimum index value would be 0 and maximum index value would be 0, 1, 2, 3. So it is str3. So minimum index value is 0, maximum is 3 because size is 4. Here also in case of columns, minimum index value will be 0, maximum index value will be 1. So 0, 0. So it would print lowercase a. In this case, it is asking us to print the second string. So it will start printing from E and it will end up at null character after printing G. So E, F, G. Here 0, 5. So first string it says fifth character or other character with index value 5, that is sixth character. So it will say 0 is here, then 1, 2, then after this we have, it has reserved one null character. So 4, so 0, 1, 2, 0, 1, 2, 3, then 4 is E and 5 is F. So this will print F. In this case, fourth string, that is 0, 1, 2, 3. So index is 3. Fifth character, it has gone beyond it. So what will it print? We don't know. So whatever we have not initialized, if it is beyond range, we don't know what will be the result. Here, unlike C, it will print the address. Name of an array is address. Here again, 3 rows of 4 columns each. So first row is this, next is from here up to including this 4, and third row is this. So 3 rows, 4 columns each. So here we have written individual characters. So here str40, it will start printing from str40 wxy. It will keep on printing unless it encounters null character. So it will print w, x, y, z, lowercase 1, 2, 3, 4. These are not the numbers, they are the ASCII codes. They are characters 1, 2, 3, 4 and capital A. It will print up to and including capital A. It encounters null character in memory, so it will stop there. Here str42. So first row is this, next row is as usual this 1, and 2, it means the last row 2. So it will start printing from this, but it will stop here. So it will print capital A only. And in this case 2, 2, so 0, 1, 2, 2, it will start, or rather it will print only capital C because we have asked it to print only character. So now let us execute this program and see what happens. Now in this particular setup, in this particular release of you can say C++, if we have not initialized a character array, it initializes it with null character. So you can see here it has printed nothing. In this case it prints capital A, B, C, D. In this case, okay, in this case it will print what? Only lowercase a. It has printed like this. Now next one str31, so it will print EFG. It has printed EFG. Now here it will print f, lowercase f, because this is location is 0, 1, 2, and then following character which is null character because the size here is 4. So 0, 1, 2, 3, 4 and 5 f. So it has printed, it will print f. So you can see here it has printed f. Now in this case it is supposed to print some arbitrary value. It has gone beyond the range. So as we have already discussed, if we have not initialized a character array, or if it goes beyond the range, it prints null character. In this particular release of the compiler, we don't know what will it do. So we have not initialized, so we cannot depend on it. Here it prints the address. Okay, so this is the way by default addresses are printed in hexadecimal format, 0x 7FF something. Next time when we run the program, this array might be occupying some different memory locations, so the address would change. So let me erase this. Now here str40, okay, 0, so it will start printing from W and it will keep on printing unless it encounters null character in memory. So now you can see here it has printed this WXYZ 1 2 3 4 capital A and stop. Here str42, so it will start printing from A, but it will stop at null character itself. So you can see here it has done like this, okay, and here it will print only capital C, because second row number 2, that is third row, character number 2 means third character. So it is first character is A, second A is null character, this is C. So it will print capital C. So you can see here it has printed capital C. As many times as we like, we can print, the address would change. So if I say execute this, now I can see here address has changed. But those values which we have not initialized in case of character arrays, they are treated as null characters. Again you can check, it has gone here, a different address. Okay, so in case of character arrays, whether it is single dimensional or two dimensional, if we do not initialize a character, or if we provide an index value which is beyond the range, this particular implementation assumes null character. So we should not depend on it. The compiler implementer may decide to assume some different value. In the next video, we will study structures. There are two types, struct and union. That is all in this video. Thanks for watching.